Hey team, I'm Maddie. Welcome to ScienceSideUp, and today is part 2 of our carbon dioxide climate forcing video, where we're going to answer the question, what happens to Earth's temperature if carbon dioxide levels are doubled? So in part 1 of this video, what we did was we took a change in carbon dioxide concentration. We went from the pre-industrial level of 280 parts per million to a doubled level of 560 parts per million and converted that change in concentration to a change in forcing, or again, we're going to think about that as a change in energy, where our number here is 4.34 watts per meters squared. And what we're going to do today is take my change in forcing and get a change in temperature. So we have a very simple equation that's going to get us there. Let me write it up on the board. Here's our base equation. My change in equilibrium surface temperature, this is the number we're looking for, equals some number represented by a lambda times my change in forcing. So we have this number, check. What about this lambda? Because what we're trying to solve for is this guy, my change in equilibrium temperature. So what does that lambda represent? Oh, shoot, these are my notes from the last video, not this video. That's not helpful. Lambda is called the climate sensitivity parameter. And what's kind of cool about this number is that it's not dependent on what's trying to change Earth's temperature, right? It doesn't matter that we're changing Earth's temperature by affecting carbon dioxide. We would use the same climate sensitivity parameter if we wanted to figure out, hey, how much does Earth's climate change? How much does the temperature change because of a change in forcing from a Milankovitch cycle, from a volcanic eruption, from, I don't know, replacing all of the oxygen in the atmosphere with sulfur dioxide? That's a bad idea, don't do that. But the point is, no matter what is doing the forcing, Earth's climate is sensitive in the same way. So climate sensitivity, which is 0.7, and that should be a very weird unit, but it's degrees Kelvin meter squared per watt. So this 0.7 climate sensitivity. How do we calculate climate sensitivity? Great question. The basic idea of how you do it is this. We scientists, climate scientists, right, people who very carefully measure these things, know what Earth's climate was like at different points in our history. And we also have some idea, at least, of what caused the climate to change. So 10 million years ago, the planet was about 10 degrees warmer than it is right now. And our atmosphere looked very different. There was more carbon dioxide, there was a lot more methane and other things. And so we look at what the climate used to be like, what it changed to, and we understand what caused it to change. And so by comparing the climate at different points and seeing how long it took, how sensitive the climate was to a change in, say, greenhouse gases, Milankovitch cycles, whatever have you, you're kind of able to come to a number like 0.7 that you and I can look up in a textbook. I think those are the main points I wanted to make about climate sensitivity. Yeah, so that's just kind of, I hope you understand that methodology. I pulled this number from my Wallace and Hobbs Introduction to Atmospheric Science textbook, but I hope you have some sense of just the amount of work, like the decades upon decades of work by scientists that has gone into coming up with this 0.7 number. So I really want to emphasize that I'm not just pulling this out of thin air. I'm not grabbing a number number to make my answer come out to what I want it to be. This is what we understand Earth's current climate sensitivity to be. And I did say earlier that Earth's climate sensitivity can change. Totally true. By change, I mean like a billion years ago, it was probably different, right? It's not gonna change in 100 years, or probably not even change noticeably in 1,000 years. I think that's all the caveats. I think we're good. And now all we have to do is very simply multiply our climate forcing 4.34 by 0.7 to get a change of temperature of, I wrote it down, of 3.04 degrees Kelvin. So that means that if we double our atmospheric carbon dioxide from pre-industrial revolution levels, then we should expect to see a temperature increase of about 3 degrees. And that's, you can think of that as Kelvin or Celsius. Fahrenheit would be different. It's like 4-ish, maybe 5 degrees Fahrenheit. Yeah. Notice what we didn't do, right? We didn't use a climate model. No computer models necessary, right? This was all, I did all of this on a chalkboard with a calculator after looking up some specific numbers. And my point here, the point I really want to drive home is that this question, what happens to Earth's surface temperature if we double CO2, is a very simple one to answer, right? We know exactly what it's going to do. Maybe this is really 2 degrees Kelvin, maybe it's really 4, right? There's a little margin of error on this, but we know it's going to increase Earth's surface temperature, increase it noticeably, and increase it quickly. So if you ever hear someone try to say that like scientists don't agree or the science isn't back on carbon dioxide warming Earth's surface, more CO2, warmer temperature, they're lying. Or they're grossly misinformed. We don't need a complex climate model to tell us that this is going to happen, right? This is very, very simple, settled science. Where there is debate, right, where there are the uncertainties is, well, how fast is this going to happen? That's a great question. I don't have a good answer for it. We're gonna dig more into that later on in this series. When the temperature warms by this much, what does that mean for, say, me, an individual human living in the American Midwest, right? Will I see more severe weather? Will California see more droughts? What about hurricane frequency and intensity? So we know the climate answer, but what we want to know more often than not is that, well, then what's the weather answer? How will this change in climate affect the weather? Because the weather is what affects individual people, and it affects industry, it affects, weather is what costs money, right? A hurricane coming through your city is devastatingly financially. So one of the main reasons I'm making a video on this specific series, and I'm trying my best to make this understandable to people who, unlike me, have not spent their entire adult lives doing math and science and specifically studying the weather and climate and the atmosphere, is there's a lot of bad science. It's not even science, there's a lot of bad information being put out about what people like me know or don't know, or what we can and can't predict. And I want to give you, people of the internet, a sense of what we can and do know very clearly, right? And then separately, where there is room for debate, right? Because there's room for debate on how will hurricane frequency and intensity be affected by a warming climate. That's a great question. There's lots of papers being written about that. There's not papers or research into does more CO2 mean warmer temperatures, because we know that. That's very settled. And it took me 8 videos to get to this point because I want you to understand this with some depth. Anyway, I'm rambling. Okay team, that's all I've got for you today. I hope you liked this video. I hope you are well and those you care about are well. Please like, subscribe, don't forget to be kind, and I will see you all next time. Bye team.